Okay, hello. I wanted to make a video on XState and typing because I learned so much from David and his presentations on state machines. And even though I haven't used XState in any projects, because my initial impression was, oh, this is overwhelming. There's so many concepts and a lot of API surface there. I have learned so much looking at his presentations and just playing around with it. And that's basically just how I learn. I have to take things apart and put it together and twist and turn it and often do a ton of mistakes. But that helps me to really understand the concept. So I think I've gotten to a point now where I really start to see where state machines are super beneficial and how you can design APIs to take advantage of typing. I think. So the idea here is really to take a look at the XState API and introduce some suggestions for inspiration. And a disclaimer here is that I haven't looked at the whole surface, API surface, because there's too much for me to take in and iterate on. It would take too long for me. But hopefully I've gotten to some points for inspiration. So that's what we're going to talk about. But first, let's talk about why does XState have challenges with TypeScript? And it's not XState itself. It's just that XState is declarative, and declarative APIs are challenging to deal with in TypeScript. So TypeScript comes from this world of C Sharp. You typically do classes and plain imperative stuff, and that's where typing really works well. But in JavaScript we do a lot of declarative stuff and functional stuff, and the typing there doesn't work as well. Just look at a simple thing like a pipe. So if you're going to type this, you can't type this in a generic way. You have to explicitly type the pipe for having 1 argument, 2 arguments, 3 arguments, where the complexity here is that one operator decides the input of the next operator, decides the input of the next operator, and so on. And I had the same experience with Cerebral. Tried to put TypeScript on top of it, after the JavaScript implementation. It had a declarative API. We just couldn't make it work. But that doesn't mean that declarative is bad. It's just very challenging. So I believe this is an older way to type XState, where you explicitly type the schema and you have the events, and then you have this general context. And this is not ideal for 2 reasons. One reason being that there's no inference here. So you're basically writing the same structure twice, and you just have to keep them in sync, right? It's not like you type the structure once and then it's inferred here. So you basically, every time you change a state, you have to change it to different places. The other thing is that the context here isn't tied to a specific state, and that is what state machines are really about. It's okay, in this state, this is my context. At least in my experience, that's the power of a state machine in terms of typing, because then you can check what state you're in, and then you know what the context looks like in that specific state. It's super, super powerful. Anyways, so I guess moving down to version 4.7, you got type states, and this is more in tune with what you really want, where you basically give the states and you define the state here as a value, and what does the context look like when you're in this state. What I'm a little bit confused by in this example is that you have this basic context, which I don't understand why you need, because when you define the context in the different states, that is the context. So I don't understand why we have to pass this in, because you would end up with the same stuff. You wouldn't have to point to this user context. You could just say that in idle, we don't have a context. And in loading, you might have a user. Is that the case? Yes, I would say that you don't have a user in loading, and on success you have a user, and then on failure you have an error. So you would just explicitly type exactly what this context should look like in each state. And then that's something, I'll get back to that. Remind me, well, I'm recording this, I'll have to remind myself about assigning state or assigning a context. Anyway, so I would do that explicitly. But the biggest problem here is when we look at here, we can see that this is the same example. When I'm looking at the states here, I'm not getting any help. So it's not inferring what states I actually have from my typing, which is really like, I think this is the most important thing that needs to be there. Or you can put in the wrong states and you don't really get that help you want. Okay, so that's like an introduction. Some things I identified. I'm not saying like this is not correctly implemented or anything, because this is really, really tricky to do. And some of these things is just impossible to do. You will have to change the actual API surface to fix this. So I have some suggestions on that as well. But okay, let's go through my findings and see how we can improve some things, possibly. So we have the same, I'm calling it T state here. It's the same thing. You have a value and you have a context. And then you have the event, which has like a type. So one thing we can do is we can, based on the state, we can infer the schema. And what that means is basically when we have a state of foo and bar with different contexts, we can actually infer that. So if I remove this, it tells me that, okay, you haven't implemented all the states. It says, okay, you have a foo, and it says you need to define the bar. That's perfectly okay. And then when we use the on transition thing, it knows what events I have, so it's able to do that. And when we have, oh, is it, sorry, is it supposed to be, oh, sorry. And then when I tell it to transition to a new state, it also knows which states I can transition back to, right? So this is super important. So when I change my states to something else here, bar 2, it starts complaining about what I'm doing here. So bar 2, right? This is what you want. Okay, but the thing is that XState isn't just like one level of states, and that's where like it's super, super complex in terms of typing. Oh, but one more thing. Before we talk about nested state, it's also that you see that we're not initializing anything here. We're not saying what's the initial state and what's the initial context. And the reason for that is because it's impossible. Because we have to be explicit about what state do we have and what events do we have. We can't infer that from the definition. That would be literally impossible. And you can't combine explicit state with generics. But we need generics to figure out what context do we need when we initialize with a specific state. So here's what I mean, where TypeScript forces you to change your API. So you can't have initial and context here. You rather have to do that, for example, when you create the machine. So in this case, I'm creating the machine, and now I'm saying initialize this with the foo state. And now I have a typed context here. So if I were to change this to, I want to initialize with bar 2. Now it says that this is wrong. This is not what we want. What we want here is, yeah, bar, and that should be a number. And to me, sometimes TypeScript helps you build a better API surface. And I think this is actually better, because now the definition of the machine doesn't mix a definition with initialization. You define it here, and then you initialize it here. But yeah, so that's one thing. And then we have nested nodes or state nodes. And this is expressed in XState using, you have these dots, right? So you can have, like, you see here, we have like nested pedestrian states under red, which means that we have like red dot walk, red dot wait, red dot stop, red dot blinking. So you can see here, and it's also prefixed with a dot here. I'm not sure why it does that. It might be like relative, which is tricky in itself, like in terms of typing. But what do you know? There's actually this feature in TypeScript called template literal inference. So we are actually able to deal with this. So imagine that you do the same kind of typing. We have the state of foo, and we have the state of foo.bar. So we explicitly type those. The thing is, when we actually implement the schema definition, we want this to be nested. We don't want this to be an explicit state, but this indicates a nested state. And we can actually use, so you can see here, I'm doing some crazy stuff here. Extract level 1, extract level 2. And then I'm doing this explicit nested typing here, which also looks crazy. But what this allows us to do is that if we remove this now, it allows me to go into this, and now it actually understands that I have a foo state, right? So I have foo, and then if I go in here, I can say I can point to states again, and now it knows I have a bar state. So it actually knows that based on me doing this. So if I change this to bar 2, suddenly this needs to be bar 2. So this is actually possible to do. Again, this is like just a simplified example. Like, it might get way worse than this, like way more complex. And you also have these, as you see, this prefixed with a dot, which should be able to deal with that. Because you can actually use a template literal string as a type in TypeScript. So you could like create like absolute and relative types, I think. But yeah, but anyways, I just wanted to show the craziness of actually being able to type this into a nested structure. And then we have something even more interesting, and that is, well, equally interesting, I would say. And that is typed effects. So like in XState, you have actions and guards and services, I believe, like different concepts that are like external. So what you want to do in your schema is you want to reference like an action by just using a string. The problem is that you want to ensure the typing of that. So do we have an example here? Actions. Yeah, so for example, here you have like activate. And then that points to this action, but like you have no idea what this context or this event is. But it was actually triggered on a specific state on a specific event. So we actually do know, we can help, like we do know the context and the event data. So we can figure out if these are correct. And the way we can do this is that we can, in our options, like these are considered options. You see this, actions here. We say that it takes a context and it takes an event. And then we have this crazy thing called a matching actions. So we still have this nested thing here, maybe a little bit unnecessary. Oh no, sorry, we don't have the nested example here. But that doesn't matter because this is pointing to a different improvement, where we basically say that, okay, we can either point to when we, let's see, look at the actual thing here. Oh. So when we point to an event, we can do like this, right? We can point to a transition to this thing, or we can do target. And currently actions is typed like as just as a string, which I think is also allowed. You can have like an array or just a string. But my point is, I don't even want to explain this stuff. I just want to show you what it does. So what's important for this to work is that as part of the state machine, you actually define the actions and the services. Like you type what the actions and services are expected to deal with. So in this case, I have an action called log foo, and I'm not giving it like the complete context or anything like that. I'm just saying, okay, log foo needs to grab a foo type, a foo property from the context, and that needs to be a string. That's all I'm expressing. I'm not expressing like this is the context it gets. It's only that, okay, this state machine needs a log foo action, and I will give it like the foo property. And then what I do is that I give that as a type. And then when I implement this, I'm able to point to log foo here. That becomes one of the actions I can use. But not only that, because currently this state, the foo state, it says that the context here, yes, it has a foo property and it has a string. So that matches the expectation you have set for the action. If I were to change this into a number, you get an error. This is not, you don't have any valid actions for this that matches, like the expectation here doesn't match what you set up here. So it's not a valid action anymore. But if I were to change foo, this into a number, oops, it's suddenly back. Or if I was to like remove this, it doesn't have any expectations on its arguments. It would work no matter what I put this to be, right? It doesn't matter. So the point is to match the arguments that is being passed into the action with the expectations of the action, which is super powerful, right? So you can actually just say, okay, these are, so this also helps you in the implementation. So if I were to, let's see, let's do whatever, log foo, let's do string again. So when I actually implement the actions here, it actually says that, oh, you're missing an action. And it's log foo, and it already knows. Okay, so I promise you will actually get a foo property here, and it will be a string. And I know that because I'm only using log foo where it's valid in terms of state and event, which is pretty cool. Okay, but that's not all. This also helps without doing anything specific with the assign. So if we look at the value bar here, we have a context bar, which is a number. And then with assign, now it knows that, okay, this should be bar. And if I were to change this to a string, the assign would understand that. And it's the same if you use like the, let's see, if we were to use like this, this will be bar, right? And if the event, it also types the event there. So you know exactly what's in there, which is super nice, right? The thing I don't understand here is that there's a partial, I don't understand why it's partial. I would expect when I go here and I actually assign, I would expect this to force me to return the new context. that's how I think about state machines, is that when you move to a new state, you have to ensure that the context is valid. You're replacing the old context with a new context that is valid for this specific state. So it wouldn't be a partial. You would have to actually return bar. And if I had foo, like I would have the same foo string here, right? Which says that, okay, I'm in foo, I'm moving to bar, which means I just want to add bar. I would explicitly have to still, I would have to insert like bar, and then I would have to move, I would have to add foo from the existing context. Like either I would explicitly add it here, or I would have to add it from the event or the previous context or something like that. Like you basically replace the context on every transition. That, in my experience, that's more predictable, and also the typing works a lot better, and it ensures that the state is actually, like the context is actually correct related to the state you are in. Anyways, maybe I'm mumbling a lot here, sorry about that, but I have a lot of thoughts on this. Anyway, so I guess you got the picture there. And then we have the events. So currently in XState, you can type the events as any, so you can say type, and then you can do whatever you want there. Foo string, bar number, for example. But just like the state, where you have like a value and a context, it would help to have a type and data, because this allows you to split them up. Meaning that we can just go to the end here. We don't have to look at all the typing. What it basically means is that when you send foo, and as you can see here, the foo event doesn't have any data. It doesn't require the second argument. But bar has a data and requires the second argument. So it just gives more flexibility in the signature of the API to do the same thing. Have like, okay, an event needs a type and it needs optionally data, and that allows us to split them up so you can pass them separately. Yes. Okay, so a conclusion. Again, I haven't looked at the whole API surface. There's a lot of complexity in nested and parallel state nodes. This might not work. It was just interesting to see how far you could take it. And I don't know if it actually makes sense, because the way I understand it, the next version of XState is going to have a visual editor. And for XState, to me, it seems that due to the complexity of the declarative, like the configuration, it would be better that you actually build these things visually, and then the visual tool doesn't only produce like the runtime code, but it also produces the typing. And there is already a project that converts like a runtime code into safe typing, like for consumption. But that tool doesn't actually know if, maybe it throws errors if you have done something wrong. I don't know. Probably not. It probably just shoves everything into types. I'm not sure how it works, but no matter, like with a visual tool, you could actually ensure that when you use like the initial property, you have to use one of the existing states, for example. So you can have like visual typing or visual safety. And then you produce the actual typing, which is like just consumption typing, which is way simpler than adding typing for the actual configuration of the state chart or the state machine. Because this, actually making this work, it would, I'm very confident you would have to break up the API a little bit to separate definition from initialization. And there's so much complexity in the nested behavior and the parallel behavior that I'm not sure if it's doable. It would be a like super fun project to see if you can make it work. But yeah, I'm not sure if it's, I would much rather put like efforts into a visual editor and say that this is how we're going to build these state machines and state charts in the future. Anyways, so there's no need for all this complex typing in configuring the machine or defining the machine. But yeah, anyways, this became quite a long video. I hope I mumbled a little bit back and forth. I hope it made sense. And again, I might be wrong about this. It's just my experiences. But I hope it's useful in some way. Okay.